Hi and welcome to another tutorial. In today's lesson we'll learn all about Dijkstra's algorithm. So anyways guys, let's jump in. So firstly, what is Dijkstra's algorithm? Basically, Dijkstra's algorithm is used to find the shortest path between a source node and all other nodes in a graph. We are going to be using the table method to display Dijkstra's algorithm, and you'll see it's pretty easy to do in the example. So here we have our first example, and the question states, we have to find the shortest path from node A to node F. Now you can do this a few ways. You can do this visually by just, seeing which path is shorter, etc. But we are going to use the algorithm to actually do this. So the first thing that we need to do is we need to create a table like this. We are going to start at source A. So therefore what we will have is we will put A up there, and then we'll put all the other nodes in here just like this. So now that we have that, now we have to start filling it up with some values. So the first thing that we have to look at, the distance from A to B is going to be 2. You can see 2 is down there. And then you can have the distance from A to C is 1. So that's that distance there. A to D, there is no direct path because you have to go through C. So therefore we don't need it at this moment. And the same with E. You have to go through C or some other way, so we'll just leave that. And F is exactly the same, so we're going to leave that. So now once we have our first row complete, what we need to do is we need to find the next starting point, so the next node that we are going to put down here. And basically all we are doing is looking for the lowest value. Now the lowest value here is 1, so that is the shortest path right there. 1 is smaller than 2, and so once we have that, then we can just drop that down automatically to the next row. We know that that is going to be the next starting point, so we've moved from here to there, and then we keep on going. Now this number is pretty important because it is the distance that we have traveled already. So with the next lot of numbers that we have to take that into consideration. So now what we have is when we go from C to B, there is no direct path, but because we already have this path over here, we can write 2 over there. Now moving on, C to D, we can see that the distance is 3 plus 1 will give us 4. Then we can have C to E, which is 4 plus 1, which will give us 5. And C to F, there is no direct path, so therefore, and there is no previous value, so therefore we just have to leave it for now. So now if we look at all of this, we can see that this area over here, all right, is our smallest value, so therefore we drop that automatically, and that is going to be the starting point. Now like I said, that number is quite unique because now we have to add +2 to every other distance that we have. Now once you have 2 boxes like this, you can really just cross off all of these the columns really, because you don't have to keep on writing it, but for the purpose of this video I'll just keep on writing them. Cool. So now we look at the distance from B to D. So we're right here. B to D is going to give us 3 plus 2, which will give us 5, but we're not going to write 5. The reason why is because we already have a shorter distance over here, so we are just going to drop down that 4 to there. Then we're going to look at the distance from B to E. So we have B to E, and there is no direct path, so therefore we can take that value over there. But then we do look at B to F, and you can see that that distance is 5. So 5 plus 2 will give us 7. And then again, all we have to do is the same thing, find the smallest value here, draw a box around it. Now we have that as our starting point. So I'm going to put D down here. I'm going to put +4 because that is our special number. And then again, like I said, you can just fill it up with everything, or you can just cross off everything that you don't need. So now we're up to the last 2 sections over here. So we have D to E. So when we look at D to E, there is no direct path, so therefore we will take the previous value. D to F, so D to F is going to be 4 plus 1, which will give us 5 also. Cool, so now we're ready to draw a box around something, but we have two values that are exactly the same. So all that means is, look, it doesn't really matter which one you choose because it's just going to show us the starting point. So I'm just going to put E down here, all right, and then the next one is going to be plus 5. We have the 2, we have the 1, we have the 4, we have the 5, and now the final one is going to be this value over here, so E to F. So E to F, you can see that the distance is 2, plus 5 will give us 7, but we can already see that this value over here is smaller, so we are going to write that down. And then to finish it all off, we are just going to put F down here and we'll just put the 5 down there. Cool, so now once we have all of that, now what we have to do is we have to find the shortest path. So we're gonna look at this, so we can see that 5 is the weight of the shortest path. So what we're going to do is we're going to draw a line up and we're going to make sure that we go through all of these 5s. So just before it starts to change to this value over here, so we want to keep all the 5s together, and then we're going to look over and we're going to see what letter it corresponds with. So that's a D. So now what I'm going to do is I'm going to go and move to the left, and I'm going to go all the way until we have hit that D column. And then again, we're going to repeat that process again. You can see that there is a 4, there is a 4, and then it stops up here. So now we are going to go up to that area over here. And now you can see that we are looking at column C. So we're going to move that over to that section there. And then we're going to do the same thing again. So now we're going to go up, but now this time it's going to go all the way back to A. So now if we have a look at that, we will see that we have all of those letters right there. So if I put that up, that will be A, C, D, and then we have F. And if we look at all of those values, so A to C is 1, all right, C to D is 3, D to F also is 1, so 1 plus 3 is 4, plus another one is equal to 5, and you can see that this was our value down here. So yeah, so that is our example on Dijkstra's algorithm. Anyways guys, I hope you learned something. Thanks for watching, and I'll see you guys in the next video.